Good morning and welcome to the 2023 DiLCo Lecture Series on Digital Language and Communication after our summer break. We're going on again. I'm Yanis Androutopoulos from the University of Hamburg, and I coordinate DiLCo, a 3-year scientific network on digital language variation in context, together with my colleague Heike Zinsmeister from the University of Hamburg. DiLCo was initiated in 2021. It's an international network that includes scholars from universities in the US, UK, Luxembourg, the Netherlands, and Denmark. DiLCo is generously supported by the University of Hamburg within the Universities of Excellence scheme funded by the German federal government and the federal states. The DiLCo network aims to stimulate scientific exchange between various approaches to digital language and communication research within linguistics and to bridge gaps between interactional and computational research methods in particular. To this purpose, we organize online and on-site activities such as conference panels, methods workshops, and this lecture series. Our lectures showcase cutting-edge international research by both senior and younger scholars who draw on key concepts in socio-cultural linguistics to shed light on language variation, language diversity, language change, and language ideologies in digital communication and digital language use. These lectures are recorded and made available in an open access repository currently located on Hamburg's University video portal called Lecture to Go and accessible through our website. Each lecture is about 40 to 45 minutes, followed by discussion. Feel free to post questions and comments into the chat during the lecture. I'm delighted to introduce today's speakers, Monojit Choudhury and Sunayana Sitaram. Monojit Choudhury has a PhD and BTech in Computer Science and Engineering from the Indian Institute of Technology in Kharagpur. He's currently a principal applied scientist at Microsoft Turing and previously was a principal researcher at Microsoft Research Lab India. Monojit's research interests span various aspects of natural language processing and cognitive science, including multilingual models, NLP ethics, AI ethics, and NLP for social good. Monojit is a professor of practice at Plaksha University and has previously served as adjunct faculty at IIT Hyderabad and Kharagpur. He's also the general chair of the Panini Linguistics Olympiad for Indian high school students and founding chair of the Asia Pacific Linguistics Olympiad. Sunayana Sitaram is a principal researcher at Microsoft Research India and director of the MSR India Research Fellow Program. Her current research is on the evaluation of large language models in non-English languages across dimensions of quality, safety, and task completion, and her research goal is to improve the inclusivity of AI by enhancing the accuracy and safety of LLMs in languages other than English. Sunayana has served as convener or chair of several conferences, workshops, and special sessions, including and focus on multilingualism from an LLP perspective, which is the topic of today's talk as well. Welcome, Monojit and Sunayana. The floor is yours.
Thank you, Janice, and welcome everybody to this talk. First of all, thanks a lot to DiLCo for giving us this opportunity to, give this talk, but also more importantly, organizing this very interesting set of talks because these questions of language variation and language ideologies in the digital world are very important, and some of the questions which are very close to my heart. So the content of the talk is based on research on code mixing and many other phenomena that we observe in multilingual societies that Sunayana, I, and many other colleagues from Microsoft Research have been doing from around 2012 to 2022. Of course, we are still continuing our work on multilingual processing by LLMs and ethics of LLMs and many other aspects which are very important, and questions like language variation and influence of language on culture and vice versa are very important topics that we are looking at, but not specifically on code mixing. So this work is like 10 years of research into various aspects of code mixing, which I will try to summarize, Sunayana and I will try to summarize in the next 40 minutes or so. I will first talk about the older studies, and Sunayana will then take over and talk about how with large language models, things are changing. Uh, So most of you might be already aware of what is code mixing or code switching, but I'll still define it. It is a mixing of two or more languages in a conversation, or sometimes even within an utterance. This picture shows a bunch of tweets. These are all real tweets, uh, which were tweeted from various, geographies around the world, and you can see a lot of different languages getting mixed. For instance, I think this is German and Turkish. This is yeah, so this is Spanish and English, French and Arabic, so on and so forth. So the point is, code mixing is an extremely common phenomenon that we observe in almost all multilingual societies, where most of the people in that particular society knows more than one language and use them in day-to-day conversations. And many linguists even believe that across all multilingual societies, we will have code mixing. In other words, uh, being a multilingual society is both a necessary and a sufficient condition for having code mixing. Uh, Now, the structure of code mixing itself is very complex. Uh, it of course depends on a lot of things, like which language pairs we are talking about that are being mixed, and in what context and all that. But if you see a typical conversation, which is code mixed, and this particular snippet I have picked up from a Hindi movie called Queen. In most of the Hindi movies or the so-called Bollywood movies, we see a lot of code mixing. In fact, the saying goes that hardly anybody speaks one language in India like English or Hindi. Everybody will just mix them, and many people just call it Hinglish, but essentially it means Hindi English code mixing. And here you don't have to read this to understand anything, but the blue words here are in English. Everything else is in Hindi. And you can see that sometimes it's an entire sentence, like you will not fit in, which is English, rest of it is in Hindi, but sometimes it's just one English word embedded in an entire Hindi sentence. So it could be at word level, it could be sometimes even at morpheme level, and it could be at paragraph level or sentence level. So it's structurally very complex. But what is more interesting is the function of code mixing. What drives the choice of a language when somebody is code mixing? Why here this part is in English and not the other way around? And these are fascinating questions which linguists have tried to uncover for a century. And there are many things which people have observed which have correlation with language choice, like topic of the conversation, the emotional content of the conversation, whether there is a figure of speech like pun or humor, or somebody wants to emphasize something. But one of the most interesting thing, which I will get into a little more detail towards the end of my part of the talk, is linguistic style accommodation. When people want to show familiarity or express some sort of warmth in a conversation, people do style accommodation. And in multilingual societies, a common way of doing style accommodation is to kind of mimic the language or reciprocate in the same language which the other person is speaking, and that often leads to interesting patterns of code mixing. So what in this talk specifically we are going to do is we'll start with 3 case studies about and most of these are done on social media, but some include other data like movie scripts and so on, and try to answer these questions of how much code mixing is there, or what motivates the language choice, and even like how do we study linguistic style accommodation, and I mean, what role code mixing has to play in style accommodation. After these three studies, discussing these three studies, I will try to make some broader comments on this methodology where we look at social media as a potential data set to study this kind of phenomena. And then Sunayana will take over and talk about, in this new world of large language models, how can we study code mixing better? And, she'll probably try to make some predictions about how the future look like about this kind of studies. As I said, this was a project which has been done for last 10 years that we call it Project Melange, and has been done with collaboration with several institutes like IIT Kharagpur, IIIT Hyderabad, even Microsoft Development Center, but mostly led by people at Microsoft Research. And I would other than Sunayana and me, I would specifically like to call out this person in the middle, Kalika Bali, who has been there from the inception of this project and has significantly driven the agenda and the research work here. And also Shruti Rejwani, who I think is right now in Google before doing her PhD at CMU. And she, some of the work I will talk about was done by Shruti, who was a research fellow at with us a few years ago. And I will be only covering the linguistic variation part of it and this so-called sociolinguistics part of it. But there is a lot of work that we did on, computational processing of code mixing, for which I won't have any time to get into in this talk. So if you are interested in knowing about those, there is a EMNLP tutorial, and the link to the slides and the video, everything is here. And you can go through this 3-hour tutorial, which has a lot more detail about all the work that we did and people around the world did on code mixing. So let's start with the first case study. The question here we are asking is, people have said that code mixing happens in all multilingual societies, or linguists have anecdotal evidence or strong belief that it will happen in all multilingual societies. But the question is, how much? Can we quantify it? And is it really true in all multilingual societies we will see code mixing? So one, it's a very hard question to study if you think of it, because how do you go about and measure it, right? But with social media like Twitter, which is kind of widespread and people from all over the world use it, maybe there is a way to study this more quantitatively. And this was the question here. So it's an interesting question, because in the past, people, when social media was not there, doing this kind of study would have been very difficult. And social media provides at least one way to answer such questions. But then there is also a challenge here. The challenge is, how do we measure, how much code mixing? Because to measure how much code mixing, first we have to identify, let's say, the tweets which are code mixed. And this is not an easy problem, because if you have a tweet like this, where only there are 3 words, because I felt, which are in blue, which are in English, rest of it is in Spanish. But if you give it to any standard language detection system that exists, anything off the shelf, it will just say everything is Spanish. In fact, CUZ is not even an English word. So with all these challenges, the first thing we have to solve is then word level language detection. And we spent a lot of time building, reliable word level language detection system, which can work with noisy text that comes from Twitter. And this ACL27 paper that I mentioned below talk about mostly that, computational work. And mind you, this is like way before LLMs. Now, many of these problems can be solved much better with LLMs. I haven't tried, but I'm hoping, if somebody tries, some of these problems can be solved more easily. But yeah, at that time there existed no tool which could do it. And once we built that tool, what did we see? So if you think of it, Twitter has a huge number of languages being used. I mean, people tweet on a very large, probably hundreds or in hundreds. You will find enough tweets there. But if you think of mixing in all possible ways between these 100 languages, this becomes pretty much an intractable problem. So instead, we thought of kind of restricting the study to 7 languages: English, Spanish, French, Portuguese, Turkish, German, and Dutch. And between these 7 languages, we tried to see how much code mixing was there. We collected around 50 million tweets which belong to one of these 7 languages, and or mixture of those. And after analysis, as I said, I am not getting into the technical details here, but I'll just tell you the findings. So what we found is around 3.5% of these tweets were code switched or code mixed. Now, this is a very high number, I would say, because you know one would probably not. I mean, most of the time, when people type or write something, people don't code mix. It's mostly a spoken language phenomenon. But the fact that we observe 3.5% of tweets code switched on Twitter is itself an interesting and I would say on the higher side than what we were expecting. Now, if you further zoom into these 3.5% tweets of tweets which are code switched, there are not much surprise. So most of the languages are paired with English. So 20% of it was English Spanish, another 20 English French, another 20 English Portuguese, and so on. But we do see pairs like, let's say, Spanish and French also mixed, or French and Portuguese also mixed, and so on, but in much lesser fractions. But what was most interesting from this study was the geographical variation of code mixing. So when we collected the tweets, we actually focused on cities where these languages are spoken and sampled tweets from those cities. And you can see the cities from which the tweets were taken. And there is an interesting, so let me first explain you the chart. So let's say if you look at this graph, so this color, this blue indicate the language, English, monolingual tweets. And then there is a gray here, which is other languages and so on. And there is a part of the wedge which is white, or rather part of the pie that is missing, which is essentially the percentage of code mixed or fraction of code mixed tweet. So you can see a very small percentage of code mixed tweet in London. And then the smaller, circles here denote what are those languages that are mixed here. And the size of the circle is proportionate to the fractions. So in this case, it is equally a mix of English and French and English and Portuguese. But the number of code switch tweet itself from London was not many. Now, contrast it with a place like Istanbul. Istanbul had 13 to 14% of the tweets which were code mixed, and we see Turkish mixed with English very commonly. Again, not surprising, but also Turkish mixed with, I think, Portuguese, and no, this is not Portuguese. Turkish mixed with Dutch, and so on. Now, that's okay, all right, all good. But can you observe something very interesting here? See, in the US, you see a lot less code mixing happening, let's say, than in Europe. And even in London, a lot less code switching is happening. And on the other hand, in North America, let's say Quebec City or Mexico City has a lot more code mixing than the US. But if you look at the multilingual population of a place like Houston, which has a huge number of Spanish, Hispanic population who speaks Spanish, so you would have expected more code mixing according to linguistic, what linguists typically say. But why don't we observe it here? In fact, we found a very interesting correlation that the amount of monolingual English tweets in the fraction of monolingual English tweets in a city was inversely correlated and the correlation is pretty high, minus 0.85, with the fraction of code switch tweets. So any place where people speak English more had lot less code switching on Twitter, irrespective of what was the multilingual fraction of people who were multilingual or spoke other languages, languages other than English. So this is very interesting. And we tried to look up materials to see if there is any reference to it. And actually, we didn't find anything in linguistics specifically, but we did find cultural studies which talk about how acculturization in geographies like US is really very fast. And it seems like the aspiration of tweeting in English and not code switching is because people really do not want to assert the identity that I am multilingual, but rather give a more homogeneous identity that I am from US. So uh, that phenomenon is very prevalent in the US, a little bit also in UK, but not so much, let's say, in rest of Europe, where people do want to assert their multilingual identities. So this is very interesting. Of course, we didn't go into depth of this work further, but somebody can take this up and study, or maybe there has already been studies. Now let me move to the second case study, where we try to ask this question of what language I should tweet in. In other words, okay, fine, I'm code switching between English and Spanish, but when do I decide to tweet in Spanish? When do I decide to tweet in English? And when do I decide to code mix? Now, uh, as I said, linguists have looked into this phenomenon in great detail, and they have a lot of factors that they have identified, right? Like pun, humor, topic, emphasis, all this. And we did try to test some of these hypotheses, which were easily testable. Note that here also testing is hard because you can collect tweets using our language identifier at word level. I can identify which parts are in English, which parts are, let's say in this case, Hindi. But beyond that, if I want to ask questions like, what is the topic of this part versus that part of the tweet, or this tweet versus that tweet, then I have to build topic models. Now, as such, building topic models is not hard, but building it for code mix tweets, and specifically for certain languages like Hindi, which are low resource, it is a hard problem. So similarly, you could study emotion, right? Is it the emotional content of a tweet and the language choice and so on. So we tried studying many of these hypotheses, and most of them we could not find very strong signals in the data for. But one thing that we found very strong signals for is that, and here I'm talking about English Hindi. So we took 830,000 tweets from English Hindi bilinguals from Twitter. So we know that they are bilinguals because from the same account we have seen tweets in both Hindi and English, and also code mixed. May or may not be code mixed, but at least one tweet in English and one tweet in Hindi. And we collected all their tweets, made this data set, and now we are studying how much of the tweets are code switch, what are in Hindi, what are in English, and why, right? So the correlation that we found is the native language, which was in this case Hindi, because the speakers were all from India, is strongly preferred, in fact, 10 times more strongly preferred for expressing negative sentiment and swearing. Whereas English, you see that just the reverse, is used far more for positive sentiment. And often when you see code switching, you also see a change of sentiment. Of course, these are statistically true. If you take one individual tweet, this may not be valid, because you do see a lot of variation even within these broad statistical patterns. And if you look at topics, there are certain topics like, let's say, sports. So this chart actually shows how much of swear words were used in tweets, and the lighter blue is for Hindi and the darker blue is for English. And you can see that for all cases, no matter what the topic of the tweet was, Hindi is far more, Hindi swear words are far more common than English swear words. But some domains like sports, etc., has a lot more swearing going on than other domains. In India, cricket is a big topic for tweeting and also swearing. Movies are a big topic, Bollywood movies that people discuss, and of course politics and other current events and etc. So we wrote a paper whose title is was "We might praise you in English, but gali to Hindi mein hi denge." It translates to "We might praise you in English, but we will swear you only in Hindi." The second part, of course, is in Hindi. Uh, one thing, though, not mentioned in the slide, but very interesting, is this distribution completely changes if you consider gender of the user who is tweeting. Now, we could not do that study very rigorously because it's very hard to get the gender of a user unless the user says so. So therefore, I would put that result as an anecdotal result rather than a rigorous scientific result. But this general pattern that I described is common for men. If you look at women, the pattern actually reverses. So first, women tweets from women has much less swearing. And second is if there is a swearing, it's much more commonly common to have it in English than in Hindi. So the interesting question then is why, this is happening. And when we looked back into linguistic studies, in fact, there were a series of studies which observed similar situations in other cases. And the reason that was given is that, swearing or any emotion heavy content hits the right point if it is in the native language. But if it's a non-native language, in this case, English, the emotional part of it or the punch in a swear word really gets diluted. The mental effect that it has is really diluted. And that's probably what people are trying to, highlight here, which is being reflected in their language choice. Now let's move on to the third case study. This is more about conversations. So, I'm having a conversation with you. At what point, and I know that you know both English and German. I also know both English and German. Let's say the context of the conversation was such that we started talking in English because it was, we both study in England and we meet there, and therefore we start talking in English. But at some point, I realized that both of us are German. And then when do we start switching to German? And how does that happen, right? And if you think of it, it will be first one person who will switch and say a few words here and there of German. The other person will start replicating it, copying it. And then over time, soon the whole conversation might become all German, right? So that's what is known as style accommodation. So what's happening here is in a natural conversation, participants try to converge to each other's linguistic style. And style here means is defined very generically. In fact, it could be even body gestures, body language, the choice of prepositions, how formal is your speech, etc. But also language choice being one of the style dimensions. And why people accommodate is because it reduces the interpersonal distance. It kind of increases the feeling of warmth in the conversation. So, of course, you have an agency. You decide whether to make the conversation warm or not. You might choose not to make the conversation warm. And even if the other person is trying to talk to you in German and knows that you know German, you might just not talk in German and be very stern and respond only in English. So this is, we do it all, we know of all these strategies, right? And many a times we would use them. So we wanted to observe if we can quantitatively kind of prove or validate these kind of things in real world conversation. Now, real world conversation at large scale is very hard to get. So we tried to get as close a proxy as possible. So what were the proxies? So one were movie scripts. So fortunately, a lot of these movie scripts are available, and there was a data set which was free for research. So we could use it. And these were all Hindi movie scripts from around 32 movies. And then apart from this, we also used tweets, although Twitter rarely has a true conversation. But still, you could have this back and forth between two people, threads of tweets, and we collected threads which were longer than 4. So we called them conversation and wanted to look what happens there. And then there were some speech data sets which were conversational, and we tried to look at, there's one corpus called Bangor corpus, which is English-Spanish code mixing. So we also wanted to look at that. But that corpus was much, much smaller than these other 2 data sets I'm talking about. So what do we observe? So what we observe again was very interesting. So we came up with a metric to measure accommodation, which was that how much likely you are to reciprocate the preceding language in the conversation turn. So in the preceding turn, whatever the language was, how likely you are to replicate that language. So what is the chance that you speak in language L given the previous was also language in language L, versus what is the default chance of you talking in language L? And if you compare these two, and the first quantity L given previous was also L is higher, then you know that there is a strong sign of accommodation happening here. So those are the kind of things we studied. And what we observed was very interesting in Hindi movies, and similar findings we also observed in Twitter and the English Spanish corpus. But in the movies, those were much stronger. Probably also because script writers of movies try to exaggerate certain things. They know how people behave in real world and have an exaggerated version of this in the movie, right? Dramatize the things. So probably that's why the signals were strong. And what was the signal? The signal was, um, you know, we do see a very strong accommodation happening for only the marked language, not the unmarked language. So what do I mean? So imagine it's a Hindi movie. So therefore, the unmarked language is Hindi. Everybody is speaking in Hindi. If you randomly pick one particular, dialogue, it will be expected most likely to be in Hindi. So there, whenever somebody spoke in English, uttered a few English words in the conversation, you see that being replicated by the, other people involved in that conversation. But not vice versa. You don't see that same signal for Hindi. So because that use of a marked language is a style statement. Use of an unmarked language is not a style statement. It's the default choice. And that was the primary finding, that people seem to accommodate the language choice for the marked language. So these were the 3 case studies I wanted to talk about. Let me quickly, try to summarize or distill some of the findings, methodological findings from, these studies. So at a high level, I would say that social media is a great test bench for doing large scale quantitative studies on sociolinguistics and language variation. So that's the opportunity we have. And why? Because one is the data is very cheap and easily available. And the second is the data is also often socially grounded. For instance, I know the gender of the person many a times. I know the location of the person many a times. So I know sometimes political affiliation of the person. I have maybe historical conversation. So I have a lot of data that I know the social network, who is connected to whom, who is following whom. So all this can help me do very deep analysis. So these are all strengths. Of course, there is a challenge, a technical challenge, that you need automatic detection of linguistic structures and functions. So you need to detect what is the sentiment, you need to detect what is the style. So those systems need to be in place. Otherwise, you can't do large scale studies. But those are getting easier and easier with the progress in NLP techniques. And also, I mean, unless you are working in a very low resource language. So if you're working in fairly high or moderately high resource languages, probably this is not a big challenge. But there are a couple of weaknesses. First, one has to be mindful of the fact that these results may not be generalizable or may not be always representative of the real world. Why? because first of all, what I observe in English Hindi need not be true for English Spanish spoken in Mexico. In fact, what I observe in English Hindi in India may not be true for English and Urdu. Urdu is very similar to Hindi spoken in Pakistan. So it may not be generalizable across the whole world. And even the representativeness is questionable, right? Because if you think of it, social media is a biased sample of people. Not everybody, I mean, especially if you look at global south, only people of certain socioeconomic class is there on social media. And also if you see who tweets more, for instance, on Twitter, it's a very skewed distribution, a very small set of people. They may not be representative of the general population. So these are some of the weaknesses one must be aware of while drawing conclusions from the studies. And then, of course, there are risks. There are risks of privacy, and there are risks of reproducibility. All these studies may or may not be reproducible because the data cannot be stored and shared. So, I mean, these days, Twitter even doesn't allow you to scrape. It allows you to scrape, but it doesn't give you that free tweet feeds, right? They had Firehose, Garden Hose, and all that earlier. So in those days, those were available, and we could use them to study. So with that, let me stop and okay. So one more thing before I hand it over to Sunayana is that if you think of it, code switching usually happens in casual speech, which has very low informality. And on the other extreme, you have written text, legal documents, etc., which are very high on formality. And if you look at various digital communication medium and platforms, you would see they lie on different levels of formality. So WhatsApp, SMS chat, etc. might be pretty close to casual speech, whereas printed text, literature, news is very close to high formality. Blogs, emails, tweets might be in between. So that's also something very important to keep in mind when we are trying to study these digital platforms or data, and then trying to generalize to how people use language in general. Let me stop here and hand it over to Sunayana now.
Okay, I hope you can see my screen. So let me get started on this part. So thanks, Monojit, for your insights on computational linguistics and how and why people code switch, right? And I'm going to completely switch gears now from humans to machines. And as you may all be aware, ChatGPT came out around a year ago, and it really changed the world. And all sorts of applications that involve generative AI or large language models are springing up everywhere, from education to healthcare to content creation. It seems like these systems are going to be incorporated in various aspects of our lives, and we must ask ourselves how inclusive these systems are to speakers of different languages, and particularly as we are discussing today, those in multilingual communities who code switch. So this is really important because many of these systems will be used as tools by multilinguals. And in some cases, they may even end up replacing humans to a certain extent, right? Which may not be desirable, but many of the things that humans used to do may end up being done by these machines. So it's really important to understand what the capabilities are of these systems, right? So specifically, we ask the following two questions, right? So one is, how well can these systems like ChatGPT generate code-switched languages? And second is, how well can these systems understand or process code-switched languages? So I'll try to briefly highlight some of the work that has tried to answer these questions, although this is still a very understudied topic, especially from the point of view of these large language models like ChatGPT. So Yong and colleagues did a study on how well models like ChatGPT and other publicly available models can generate code switch text in language pairs, which comprise of combinations of Indonesian, Malay, Chinese, Tagalog, Vietnamese, Tamil, and Singlish, which is a Creole. And what they did was they tried to generate code switched data through these models and asked native speakers to rate how natural the code switching was, and also how much code switching happened and what kind of code switching it was, right? Whether it was borrowing or whether it was an entire phrase, like Monojit was saying, structurally what it looked like. And what they found was that publicly available open source models, which are actually supposed to be trained on multilingual data, those did a very poor job of generating this kind of code mixed language. And these GPT-like models were slightly better, but they were extremely sensitive to the instructions that you gave to these models, to the exact prompt that you gave them, etc. And all of these models suffered from major syntactic, semantic, and reliability issues. So from this study, basically, on these languages, what the authors said was that these systems should not be used or should be used very, very cautiously in any code switched settings for generating this kind of data. And you can imagine that, if somebody is using these kinds of systems as a tool for writing documents, etc., and they want to code switch, or they're trying to write a blog post or a tweet, etc., it's not going to be accurate for them at all if they're trying to code switch. So next, let's look at a study by Zhang and colleagues who are trying to now look at the other direction, right? Can these kinds of systems actually understand, or rather process, code switching, right? And to study this, they looked at 3 sort of canonical natural language processing tasks, which are sentiment analysis, machine translation, and language identification at the word level, as Monojit was saying. And they did this in language pairs like Spanish English, Malayalam English, Tamil English, Hindi English, modern standard Arabic, and Egyptian Arabic. And what they found was that these newer, larger models like ChatGPT are really poor at these tasks when it comes to code switching. And in fact, the older models, which were smaller and were fine-tuned for these settings, right, which had which took up far less space and were much faster and much cheaper to produce, they actually perform much better on this code switched data. Right, and it's really surprising to see that these huge models are actually not doing very well on these pretty canonical natural language processing tasks in the code switching setting. They also found that these multilingual LLMs, they're not code switching capable out of the box, right? And so this can cause real world deployment challenges, as I was saying earlier, if people are going to use these as tools, or if they are going to be used for doing computational social linguistics, right? The newer models actually may not perform that well on at least these kinds of language pairs. So that's sort of a step back in a sense. While the older models were doing better, they were not doing that well to begin with. So this is a big challenge actually when you try to look at large amounts of data or even build these systems that will interact with multilinguals in the real world. So what can be done, right? So what can we do, and what are the reasons why these large language models fail to code switch, like whether it's generating or even processing? What can we do to improve the situation? So first of all, we have to ask where the data is coming from in these kinds of models, right? And first of all, we know that these large language models are trained on data from the internet. We don't know the exact data sources for some of these, like closed. But we know that from what Monojit said, that there is code switch data on the internet, right? There is some on Twitter, there must be others on other social media, etc., right? However, the proportion of this data may be quite small compared to other kinds of data, like English-only data, or other dominant monolingual-only data. And this can actually have a major impact on the performance of these kinds of models that are trained on that data. The second thing to keep in mind is that model performance is really impacted by how the model is trained, right? And there are some phases of training, for example, something called the fine-tuning phase, which are typically done with a much smaller data set. And this smaller data set may actually be only English or only comprised of a few languages. And studies have shown that these models rely quite heavily on this fine-tuning stage for their performance. So the performance varies greatly because of this stage. So if you don't use the right data set to do this, you may be decreasing the performance of these models on on code switching or even non-English languages. So that's the other part where we would need to think about if we want to actually make these models work for code switching. the third thing is that, we've seen recently articles about the human labor that was used in order to make these models better, safer, etc., for consumption, right? And we need to ask who these humans are, what languages they speak, and how these humans are being selected. Do we have multilinguals? Are they being asked to do these judgments on multilingual data, or are all of these kinds of things happening only for English? And trying to have a more sort of participatory design approach where you really involve more people from the larger multilingual community in making these decisions could probably end up making these models work better on various languages and also for code switching. So who these humans are who are actually playing a very large role in training these models is also something to consider. And finally, when these models are being developed, they are typically evaluated on benchmarks to check progress, like whether the current model you're developing is better than the previous version or not is usually checked by running the model on some standard benchmark and looking at the scores, right? And these benchmarks tend to be usually English only, right? And this is changing slightly, and people are now evaluating on non-English language benchmarks as well. But as far as we know, nobody evaluates on code switching benchmarks when they're training these models, right? And so this means that during model development, the model's performance on code switching is not considered at all. And this is partly because there's a lack of awareness, but it's also because there aren't very high quality, large, language covering benchmarks for code switching, right? Which really need to be built urgently. So to conclude, all of these factors and the studies that I mentioned, so far that have happened on ChatGPT-like systems show that there's still a very long way to go to mimic human-like code switching. And these systems need to be used in multilingual scenarios with a lot of caution. And to make things better, we need to try and make sure that code switching is being considered when these models are being developed, so that we can do this by creating good representative benchmarks covering multiple languages, so that model developers are also informed about how well these systems would perform. And of course, we need to make sure that the humans in the loop and the users who are helping test these systems also are from these multilingual communities, so that we can ensure that their needs are being met. So with that, I'll end, and I think now we're happy to take any questions you have. It's on mute. I think you need to unmute.
Yes. Did I say thank you so much on mute? I'm sorry. Thank you so much for this exciting talk. We have around 10 minutes for discussion, and I'm very happy, or maybe Heike, would you like to moderate the discussion?
I hope you can hear me, because I'm in a very loud environment at the moment.
You're in a loud environment. So I can,
Okay.
maybe we can take turns in moderating.
Yeah, I will try. Can you hear me?
Yes,
Yeah.
we can hear you, and you have a question as well, I think.
I missed a slight part in the beginning of the presentation. So my question, I still put the question. Did you also look whether code mixing goes along with script mixing? So Devanagari and Latin scripts, and can you tell us about that? So was there English written in Devanagari and the other way around?
Yeah, no, that's a great question. So we do see a lot of weird things, interesting things happening with script as well. Broadly, 70% of Hindi on Twitter, I mean, different social media will have different percentages, different platforms will have different percentages, but 70% of Hindi was in Latin script, and 30% was in Devanagari script. And then we had a few cases of tweets which are code switched, which are entirely in Devanagari, but so the English part was also written in Devanagari, but that was a very small fraction. But it was much more common to have the English part written in Latin script and Hindi part in Devanagari in those tweets. which had Devanagari. But most common case was like the entire tweet was in Latin, and both Hindi and um, in English was written in the Latin script.
But you did not evaluate, like, as you did with the sphere words in gender, whether the scripts have an effect.
We did. Actually, it was not very interesting results, so I didn't mention it. It was like the script choice was mostly based on, is it a formal official account versus a normal user account. So most of the Devanagari tweets were coming from formal official accounts, or even like the Prime Minister of India, or some very well-known leader or somebody. But the common users were mostly using Latin script. These things are also, I think, rapidly evolving. As technology also evolves, now it's much easier to type Hindi, I mean Devanagari, in from a mobile phone than it was maybe 15 years ago. So that also should have a role to play here, I think.
We have a question by Tanisha. Please go ahead.
You can hear me now, right?
Yeah.
Okay, good. Thanks so much for the presentation. It was amazing. It's a two-part question. The data that you worked on, especially for case studies 1 and 2, is that something that is openly accessible? I mean the corpus. For instance, if I wanted to work on it, could I just work on it, or are there permissions involved?
Unfortunately not. So Twitter doesn't allow you to share tweets. What we can share is tweet ID. So we have one of the data sets available which has tweet IDs with the sentiments or the language IDs. So they are bundled as, in fact, there is a whole test bench. It's called Glucose. I can paste, or maybe Sunayana, if it's handy, you can paste on the chat. So you can go to the Glucose benchmark, which is a bunch of English Hindi data sets, including some of these, but not the entire corpus of tweet on which the analysis was done, because we can't share those. But all the data that was used for validating human annotated data, those are there, but the tweet ID and the annotations or labels.
Thank you. Yeah, if you could share that in the chat. Oh, I see it. It's already there. And the second part was, it's about case study 1. You mentioned, so there was this beautiful map with the distribution of code switch text tweets, and I think then you also had them categorized based on to what like the what did you say, the proportion of how many of the tweets were code switched. Was there a reason that you chose bigger cities? So what would be metropolitans for me? Because I can imagine that there is a contrast between rural and urban, along rural and urban divides, right?
Yep.
So maybe you could say something about that.
Yeah. There was a reason for the choice of tweets. So in many places, Twitter is still largely popular only in urban areas. I'm not saying nobody from non-urban areas don't tweet, but if you are trying to collect a lot of tweets in bulk, so that and unless it's a large-scale study, you won't see the patterns emerge. So that was the primary reason why setting the location to some bigger cities are easier. Mind you also that not all tweets are geo tagged. So that also reduces the number of tweets that you have access to by a big number. So so if you choose big cities, you have higher chances of getting more tweets. But I do see where you are coming from. It will be a fascinating thing to also look at, is there a difference between big cities and other places? Yeah, that could be a follow-up study. We didn't do that. The other reason for choosing the cities where we wanted to see the same pair of languages mixed, but from different cities. So for instance, we had Mexico City and Barcelona to see, and Madrid also, to see how English-Spanish code mixing happens in these two completely different Spanish-speaking geographies. And similarly, French-English in France versus French-English in Quebec City, for instance.
Oh, there's an interesting contrast then between I don't know, post-colonial societies and societies that are traditionally, yeah, I don't know, colonizers.
Yeah.
But okay, good. Yeah.
Yeah, and we did see differences there, not like in fractions of tweets, etc. But if you get into the structural patterns, etc., you see more differences. I mean, one thing which is at top of my head right now is I think in Mexico City we saw more integrated English-Spanish mixing than Madrid. By integrated, I mean, you know, if you take a sentence, there's more frequent switching and smaller you know, spans or runs of one language. So people are switching really heavily. Whereas in, you know, Spain, it was more like maybe a few terms in English, but rest of it is in Spanish, or an entire phrase in English and rest of it is in Spanish. So we did see some structural differences.
Okay, great. Thanks.
Great questions. Thank you so much. I have Jacques coming up.
I hope you can hear me. Yeah, all right. Thank you so much for the very insightful presentation, first up. And second up, I have a question regarding the very beginning of the presentation, where you mentioned that code switching, to identify code switching, especially on a very large scale, you need to do identify it by a word level language detection, right? Have there already been tests or studies about using large language models like ChatGPT for identifying code switching through that same way?
Maybe Sunayana, you can answer this.
Yeah, so there have been very limited studies. So only one study actually that I know of, and that's also only on a couple of language pairs. And it seems like it does a reasonable job for the higher resource languages, but for the lower resource languages, it's still not there yet. So it still seems like, you know, it's going to be challenging to do the word level language ID, even with ChatGPT.
Any other questions?
Yeah, I just want to ask something here. This is kind of surprising because the GPT uses subword tokenization. So I would have expected that it's better on also on code mixing, code switching. Could you comment on that?
Yeah, so what we found actually is that these GPT models in general are very poor on non-English languages for anything. I mean, for any kind of tasks, right? So especially for languages that are not written in the Latin script, because the tokenizers are very inefficient. So basically they break the word up into too many subwords, which leads them to losing context and so on. So we have some work on that, on trying to see, you know, not for the code switching setting, but just for the multilingual setting, like different languages, how well it performs. And it seems like it performs reasonably well for Latin script languages, which are like the top 10 in terms of resources. But after that, the performance drops off quite a lot. So that it's a similar case for language identification, although language identification is reasonably, you know, it's like an easier task to a certain extent, word level language identification, because you can get quite far just
She would have another question if it's possible, given the time.
I think, yes, Tanisha asks for a last one, maybe? We can take that. Go on.
Thanks a lot. This is to go back to my previous question. And you mentioned, I think that was case study 2, where you mentioned that code switching often happens to accommodate for style choices. And then you said the definition of style is relatively open for you. I was wondering if you've done some work, or if you came across work which also looks at that with stance taking. So if especially, like, for instance, like football talk on Twitter, if there is interesting code mixing, code switching that happens to take stances on, A, if you have an intuition if that happens, and B, if you came across work that goes along similar lines.
Yeah, so that's again a very interesting question. So I haven't seen specific work on stance, although I mean, my gut feeling will be, in general, it won't be correlated, but in some spatial situations, stance, I mean, some particular very niche cases, stance and, language choice might be correlated. And I will give you one example in a moment, which we saw. But people have seen, a strong influence of power structures in accommodation patterns. So usually so you can think of it as this, that okay, there is a line on one end is person X and another end person Y, the two interlocutors, and they are more or less in a friendly conversation, so trying to accommodate each other's style. But the powerful one, I mean, let's say it's a skewed power equation here. So the powerful one will move a little from their original style, and the weaker one will move a lot more to accommodate. So it's like you try to mimic the style of the person who is more powerful than you, that's, let's say, your boss, more than your boss trying to mimic your style. That's why PhD students kind of mimic their professor styles, and eventually become like their professors, if you will. But jokes apart, in stance, there was a very interesting thing that we observed. So if you remember in the first case study, I said there was a lot of Turkish and Dutch code mixing in Istanbul. So when we presented this result to a linguist from Turkey, Seza Dogrues, I think is her name, she was initially surprised, because I read the literature and found that there are small communities of Dutch immigrants who live in Turkey and they might code mix, but having it at that scale was something surprising. And then what Cesar said was, it was the dates in which we collected the data, because around that time there was a big what do you call it, some sort of international politics related event, or some sort of a tussle going on between Turkey and Netherlands, and therefore a lot of tweets were about that event, and there were the satirical tweets which were using Dutch just as a satire. So yeah, so it was a stance, I would say. Turkish people who were opposing the Dutch people, that's they used code mixing in a particular way to show their stance.
And let's take a very last one put in the chat by Anna Maria, who asks, do you see any connections between your frameworks and the notion of translanguaging? That's a nice question, I think. That's a clash of paradigms, in a sense.
I'm not sure if I understand translanguaging. If you could explain it in one sentence, maybe I can try to.
Anna Maria, would you like to do that, or shall I?
Sorry. Yeah. I was just wondering, I know that this is a big debate in sociolinguistic theory, right, between this terminology. I'm sure that Janice could answer better than me. But I was just wondering whether in this type of research in the digital communities, how can we really integrate a theory of translanguaging? That was my question. I don't know, maybe I'm sure Janice would have a better answer than me.
Well, translanguaging is this notion that originally comes from bilingual education and basically postulates that language practices flow across ideologically defined boundaries of languages. So the main idea, one of the main ideas there, is that what we perceive as distinct languages is an ideological construct, and when people do language, they basically go beyond and they ignore in practice the set boundaries between, let's say, English and Hindi. I think that's a tricky question, actually, because it's a completely different, let's say,
approach,
theoretical approach. Yes, and a lot of the computational work rests on operationalizing boundaries between languages.
Yeah. But this is a very interesting question, and at least in the context of English Hindi, this has been raised a lot. There was a work which I think the title goes something like Rise of Hinglish, and it says that Hinglish, or as I defined in the beginning, right? It's mostly I just called it Hindi-English code mixing, but it's not that simple. And many linguists have tried arguing that Hinglish is more like a first language for many people of the current generation, because that's what they have been hearing from their parents, always mixing. They have never heard their parents. So you are very right that many a times it's difficult to draw these boundaries. And we did one particular work in that context, which was how can we pick a word? There are lots of English words in Hindi. The reverse is not that true. Like, you won't say there are lots of Hindi words in English, but at least there are lots of Hindi words used in English words used in Hindi and the question is, which of these you could call as borrowed already, and which one you could just say, okay, the person is mixing. It's a very hard question because you can't, I mean, it's sometimes difficult to probe the mind of the speaker to identify. So we did some, support studies using, what happens in print media with this particular word, what happens in, different levels of education, different registers, like users with different levels of education, different gender. So we try to see, the variation, etc., and try to come up with a metric for that, a quantity to say, okay, this is the borrowedness score of this particular word. But it's a very interesting question. For instance, the example I showed, if you remember the blue word in the final sentence in the movie dialogue, it was fancy. Now, fancy is so common. Like, I heard, I grew up hearing the word fancy, and I can't even tell a Hindi equivalent or a Bengali equivalent of the word fancy. It's just in my Bengali or Hindi register, I use fancy as a Bengali word. So it's a great question. Yeah, I think it's very hard to kind of include this kind of information in these studies that I was talking about.
Well, thank you so much of reflecting and having us reflecting on these methodological challenges as well, which are very much in the heart of what DiLCo is about. Thanks again for the presentation and the discussion, and we'll follow up. Next week, we have our Methods Day on site and on webinar streaming. And today, in 4 weeks, we'll have another talk by Britta Schneider talking about language ideologies and large language models, which is a great complement to Monojit's and Sunayana's talk of today. Thank you so much.